Hello students, welcome to Spectra Education Academy. In this video, I am going to explain VSAQs in the chapter electromagnetic induction as well as alternating currents. The first question is, state Lenz law. So you need to write the statement. According to the law, according to the law, according to the law, the direction of induced current is always such that it opposes the change in magnetic flux. The change in magnetic flux that is caused by it, that is caused it. So the reason for the induced current is change in the magnetic flux. So the induced current itself opposes the magnetic flux. So this is what the meaning of the Lenz law. So altogether, EMF is equal to, we write d pi by dt for the case of Faraday law, but we, according to the Lenz law, we give negative sign in addition to the Faraday law statement. Yeah, moving to the next question. Second, what is self-inductance? The self-inductance means the production of induced EMF in an isolated coil, due to change in the current, within the same coil, So mathematically, flux associated to n coils is directly proportional to I. You can write n pi is equal to, after removal of proportionality, Li. Suppose if this flux varies with time, so d pi by dt is equal to L into di by dt. If number of turns are 1, so you can make n equal to 1. And after that, according to Faraday law, d pi by dt is equal to EMF, that to negative. So you can substitute here, minus EMF is equal to LdI by dt. Moving to the next question. Question number 3. What are eddy currents? When large magnetic fields in a metal changes with the time, and induced EMF is produced, which makes the metal to move in closed paths. So these paths are called as eddy currents. So moving to the next chapter. So covering VSAQs from alternating currents. First question is, what is the phenomena involved in the working of the transformer? The answer is, transformer works on the principle of mutual inductance between two coils which are linked by common magnetic flux. So what are those two coils? Are primary and secondary coils. Next, moving to the next question. A transformer converts 200 volts of AC into 2000 volts of AC. Calculate the number of turns in the secondary if the primary coil having 10 turns. Okay, so get back the transformer ratio formula. R is equal to EMF in the secondary coil to the EMF in the primary coil, number of turns of the secondary coil by number of turns in the primary coil. So according to the question, this is 200 is input, which means input is given in the primary coil, 2000 is at output. So therefore 2000 volts are produced output, which means secondary coil producing 2000 volts, whereas primary coil input is given 200, sorry. We are asked to find out N2, number of turns in the secondary. Primary turns are 10. So 0, 0 cancel, one more 0 cancel. Therefore, this is going to be 100. So N2 is equal to 100 turns. N2 is equal to 100 turns, which means this is step down transformer. Yeah. Sorry, it is step up transformer because primary turns are 10 only. N2 is greater than N1. Yeah. So this is step up transformer. Yeah. Moving to the next question. The question is, what is the phase difference between AC EMF and current in the following? First one is pure resistor, which means resistor connected to AC source. Second bit is pure inductor. Resistance is connected to inductor and pure capacitor. So with the help of phase diagram, you can understand that suppose resistor is connected. So this is phase diagram. So take is, first one is for current. Take x-axis and y-axis along the diameter. When pure resistor is connected, which means this is a resistor connected to AC source. So in the theory, we read that the phase difference is 0 because suppose this is the current. Along the current only we notice EMF. So this is VR, this is I. So therefore, phase difference is 0 when resistor is connected. Phase difference is 0 between EMF and current. Between EMF and current when resistor is connected to AC source. Then next, second bit is within this. When pure inductor is connected, inductor is connected to AC source, the phase difference is 90 degrees. Thus, this you can understand from the phase diagram, even this also. Suppose if phasor diagram is taken. When inductor is connected, the potential across the inductor is 90 ahead of the current. So suppose if current is here, if you take anti-clock sense of rotation, both potential and current are considered as phasors. This is going to be potential across inductor. Therefore, the phase between current and potential across inductor is 90. So potential is ahead. Suppose if you take VL here, I will be here. So therefore, always phase difference is 90 when inductor between EMF, you can write between EMF and current. When inductor is connected to AC source. And the last one, pure capacitor. So when pure capacitor is connected to AC source, so this is capacitor with capacitance C. So you can write even EMF is equal to E0 sin omega t. So once again, let us try to understand with the help of phasor diagrams. Here, current will be ahead of potential by 90. Therefore, this is one of the diameter. This is the other one. So as I said, current is ahead of potential. Current is ahead of potential by 90. So therefore, this is going to be current. This is going to be potential across capacitance. So therefore, always it is ahead. Current is ahead. So therefore, you can write once again pi is equal to 90 degrees, or you can say pi by 2 radians. When capacitor, this is between again. So between EMF and current, when capacitor is connected to AC source. That's next. What is step-up transformer? The transformer which converts low voltage of high current to high voltage of low current. Because the reason is power is same, power in is equal to power out in the transformer. So therefore, power can be expressed EMF and current. So this is input side, EMF out and current out. So therefore, when power is constant, if EMF is maximum, if EMF is maximum, suppose if as per the definition of step-up transformer, if EMF is input side, EMF is low, current will be maximum. So output side, EMF will be maximum, current will be minimum. So inversely proportional when power is constant. Then how the step-up transformer and step-down transformers are different. Because in step-up transformer, we notice that In step up transfer, you can make it as column, step up and step down. So here we find N2 is greater than N1. Number of turns in the secondary coil greater than number of turns in the primary coil. Whereas here N2 less than N1. So therefore here transformer ratio here greater than 1. Here transformer ratio will be less than 1. Then, so step up transformer converts high voltage, converts low to low voltage of high current, low voltage of high current to high voltage of low current, high voltage of low current. Whereas step down converts high voltage of, it converts the high voltage of low currents to low voltage of high current. So this is enough to write. Next, coming to write the expression for the reactance of inductor and capacitor. So when inductor is connected to AC source, we get XL. This is called as inductive reactance. So that we get from the derivation omega L. Omega is angular frequency, so that is nothing but 2 pi f with L. So where f is frequency of the source and L is inductance of the inductor. Then so coming to the second part, this is first one, this is second one. XC is capacitive reactance. That is equals to 1 by omega C. So once again, omega is angular velocity or angular frequency, you can say angular frequency, and C is capacitance of the capacitor. Moving to the next question. The question is sixth one. What is meant by wattless component of current? The answer is the power dissipated in the AC circuit is zero, even though there is current flowing in the circuit. The reason is, suppose for example, just to expect the equation for the power dissipated in the AC circuit is ERMS, or you can also call it as a virtual IRMS and cos phi. Phi is the phase angle between current and EMF. Suppose let us say this is virtual value of current IV. This is virtual value of EMF. So therefore, the phase is pi between them. If IV is resolved into two components, so there will be one component this direction. So almost this serves as opposite. So treat IV as hypotenuse. Then this will be as opposite. Then this will be as adjacent. So therefore, the component of IV is IV cos theta here. This will be IV sin theta. Sin pi in particular. So just substitute here. Power is equal to ERMS. In place of in the direction here, you can make it as I virtual cos pi with cos pi. So therefore, if pi is equal to 0, it means they both are in the same direction. So therefore, power will be ERMS with IV cos pi, and cos 0 is maximum. So therefore, here power dissipation will exist. Whereas if pi is 90, perpendicular, so EMF and virtual value of current are perpendicular. So therefore, power is equal to ERMS, and here you need to write IV sin pi, but cos 90. So this is other component. Therefore, if cos pi 90, so cos 90 does not exist. So therefore power is 0. So this is what the meaning of wattless component of current to become 0. The next question is, in a transformer, the primary to secondary turns ratio. So therefore, N1 by N2 is 1 by 2. This you can also write it as 1 by R, the transformer ratio. If an AC of 4 ampere is flowing through the primary coil, so it means they have given I1 4 amperes. What is the current in the secondary? So I2 is the question. So we know that N1 by N2, you can write transformer ratio as E1 by E2, and R is at the denominator. So therefore, power in is equal to power out in case of transformer. So therefore, EMF 1 I1 is equal to EMF 2 I2. So we can also write in terms of turn ratio, E1 by E2 is equal to I2 by I1. So, but what is E1 by E2 is, when you here also you can write E1 by E2. E1 by E2 is 1 by 2 is equal to I2 by I1. So what is I1 is 4 amperes. So you can just continue 1 by 2. I2 you are looking for, I1 is 4 amperes. So therefore 2 and 2 get cancelled. So output side is I2 is equal to 2 amperes. So therefore less current. So maybe large EMF. So this acts as a step of transformer. Question number 8. In choosing materials for transformer course, what criteria is taken for the material in the case of its material, resistivity and area of hysteresis curve to decrease the current losses? The answer is due to eddy currents. There is a large amount of heat is produced in the course of the transformer, which damages the insulation of winding of copper to avoid this. Laminated iron core is used. Laminated iron core is used in the transformer. To which is prepared. This iron core is prepared, which is prepared by joining similar iron strips after applying the varnish. As such, the induced EMF produced is produced, which causes eddy currents. Eddy currents in each iron strips. Separately. Since iron strips are thin, there is large resistance, and the eddy currents are minimized. So the laminated core is protected from eddy currents. That's it. The other part of the question, area of hysteresis curve. So the area of hysteresis curve is small for case of soft iron when compared to steel. The energy loss per volume in case of soft iron is much smaller than steel. So less amount of heat is produced. The core can be protected. The area is less for the case of soft iron. Moving to the next question. Question number 9. What is transformer ratio? So therefore R is equal to, R represents the transformer ratio. So number of turns. The secondary you can define in two ways. Number of turns, ratio of number of turns of the secondary coil to the primary coil. So otherwise, EMF at the secondary coil, ratio of EMF at the secondary coil to the primary coil. And moving to the question number 10. Primary power transmission line feeds input power 2300 volts to a step down transformer with its primary windings having 4000 turns. What should be the number of turns in the secondary in order to get output power? 230. So therefore, just now we discussed transformer ratio, output by input. is equal to number of turns at the secondary to the number of turns at the primary. So what they mentioned is output to become 230. So therefore it is step down because 2300 turned as 230. So therefore voltage is decreased, it is step down. So primary side 2300. You are asked to find out what should be the number of turns in the secondary. So N2 is the question. N1 is provided 4000. So these two zeros are cancelled. The next 23 10 times, so 230. So therefore number of turns are 400. So therefore 4000 as 400. So therefore N2 is less than N1, which is step down transformer. Thank you very much, students. In my next video, I'll continue VSAQs in electromagnetic waves as well as dual nature of radiation and matter. But don't forget to share and subscribe with your friends and relatives. Thank you very much.